have a very special connection with this city. I first came here in 2007 as a student, and now I'm back to speak to you as a practitioner. And what I'd like to spend a few minutes talking to you about is the human dimension of FAIR data. And I think one of the things that is difficult for us is that FAIR really, at the end of the day, is a destination, but it doesn't always tell teams how to get there. And there's a quote, if you remember, there's a very famous technology blog run by Walt Mossberg of the Wall Street Journal. And his very first article started with, personal computers are just too hard to use, and it isn't your fault. And this is one of the emotional dimensions of FAIR that I want to introduce, is that FAIR, being a destination and not a methodology for getting there, it many times feels intimidating to teams. And as I think back through the variety of biopharma customers that we worked with over the past 3 years, I really feel that a lot of them would more describe their data as foul than they would FAIR. And these are all the things we're all familiar with: fragmented, overwhelming, uncertain, and lost. And the importance of really acknowledging this delta between where we are as a company and where we'd like to go is that in order to achieve FAIR data, we need a new mental model as an industry. And so with that, I'd like to talk to you a little bit about some of the initiatives we're pursuing in the open source to make FAIR data, or to make this transition from foul data to FAIR data, easier and more practical for teams. How many people are familiar with the concept of containerization in software? Great, I think most of the room. And the key idea here, we've got the visual of containers. Of course, shipping around the world was revolutionized when containers became standardized. And a shipping container doesn't care if you put automotive parts or you put toys in it or you put electronics. It really makes no difference whatsoever. And the thing that I find is the biggest single challenge in biopharma is a variety of different structures, semi-structured, unstructured, structured data, and a variety of different use cases. And so what I'd like to introduce is this concept we've been pursuing in the open source of a standard data container. And data containers should have these 5 characteristics: immutable, human readable, structure agnostic, logical, and validated. And I'm using that term validated in the context of GXP environments. So you can all check us out on the open source. We are github.com/quiltdata/quilt. And again, this is a completely royalty-free API. And I want to state that data is such a personal asset for biopharmas that open source is the only way we're going to come to a standard container that works for everybody. So these APIs need to be completely royalty-free, number one, and they need to be open file formats that give you, the user, control of the data in your own cloud. A few comments here on the dimensions of containers, data containers that we found to be important. So the first is that this concept of immutability makes iteration and compliance easier. And it seems like those two things would be at odds, but I want to talk about why that is. So as scientists, we like to tweak, and modify things. And we've come from a generation where, whoa, the computers are in charge of the data, and nobody should modify anything because who knows what the downstream effects will be. So the security, really psychological safety, is what immutable data provides. Because I know as a scientist, if I grab an immutable data set and I modify it, that I can always return it to its original condition. So the importance of immutability is to make this concept of experimenting or branching or tweaking cheap. And then the second thing is that an immutable data container, the data should be continuously checksummed or validated for GXP environments. We'll talk more about that. And the key idea here is that you want to build science in one sentence, or biopharma in one sentence, is that we want to go from instrument to scientist to filing, and we want to do that with a continuous data chain of custody, and that's what immutability allows you to do. I think the second insight really is that different levels of structure of data can be unified into a single container. And the insight here, how many people are familiar with Amazon Web Services or have used Amazon S3? So both the agony and the ecstasy of S3 is that it will accommodate any structure of data. And in biopharma, we see highly heterogeneous data sets. It's totally likely that we could have a large FASTQ, an Excel file, some images, all in the same data set. We could have some JSON metadata. So any level of structure can be found in the same data set. And the beauty of blob storage is that it includes or incorporates all these levels of structure. And of course, blob storage, or S3 at least, supports object versioning, but not collection versioning. So this is really, again, the importance of this concept of a data agnostic container for biopharma. The next pressure, which I'd like to take off your shoulders in terms of fair and foul data, is that you don't have to know the schemas of your data ahead of time. And as I talk to teams around the world, this creates a tremendous amount of pressure on teams. And they feel like they have to interview the whole company and find out what the one schema is that works for everybody. And the truth of the matter is, again, because especially at the discovery phase, data is so heterogeneous, you're never going to find a single schema for everyone. And so we've really tried to socialize this idea that instead of being planned, schemas can be discovered in a bottoms-up way. And the significance here, if you can think of at the top of the data warehouse are the databases. And if we go from the database down to the users, we're going to spend a long time interviewing and discovering types. But if we start at the bottom, if we start from the files and let users gradually harden up the schemas over time with a data lifecycle, things become much easier. And this is one of the innovations that we've been able to introduce again in the open source, this gradual schema hardening where you don't commingle all of your data, but you start with raw data from instruments, you go to refined data where it's under analysis, and then finally curated data. These are candidates for investigation that are interesting, or maybe will go on even into your IND filings. A little bit more, how many people have used, are at companies that use folders to store data? So maybe Box, maybe Dropbox, maybe S3, maybe Ignite. Okay, I think it's pretty much all of us. And there's a key weakness of folders, and I call this the tyranny of files and folders. And the main thing is the name of the folder has no necessary relationship with the contents of the data. And if you think about a validated chain of custody for something like a GXP environment, it's a real problem that data can be moved, data can be modified, and the folder is none the wiser. The other problem is that there's no single hierarchy that works for everybody. If you go scientist/department, then it's going to be really difficult to find all the work under a given department and vice versa. And we're introducing, again in the open source, this concept of logical URIs. So if you look on the far right there, you'll see at the very, very end of that URI, and the URI combines both a logical name and a location, or a virtualized location, you'll see that hash. And the significance here is that when we start to use URIs, you cannot change the name of something without also changing the contents. And this is the key realization for storage in biopharma, is you want the contents to be intimately tied to the name with cryptographic certainty. So that hash is really a cryptographic, a SHA-256 hash of all the contents of the data set. And if the contents change, then the hash must change and vice versa. And this level of certainty is extraordinarily important, again, for your IND filings. The last point I want to talk to you about is human readability. And one of the hardest problems in biopharma is getting wet science teams and dry science teams to collaborate and talk to one another. One of the reasons is dry scientists are continuously running experiments in the cloud, and wet scientists are not really always comfortable with the abstruse and different types of software. They're not going to go into Amazon S3. They're not going to write code to access the data. And so what we really want to do with this biopharma container is create a unified, self-evident format that includes data, metadata, charts, documentation, and lineage. I've got a few examples here, which you're welcome to pull up after the talk. And the key thing on the right there, we see the data, we see the lineage of the data, and then visualizations like IGV, like Vega, like Altair should be very easy for us to produce so that not only machines, but also people can verify and understand the contents of the data. Because until people agree, data isn't really data. And finally, just a few heuristics to end for you with questions every data set must answer in order to be self-evident. Where did the data come from? Why should I trust this data? And how do I use this data? We're very easy to find if you have questions for us. We're Quilt Data on Twitter, or send us an email or visit us on quiltdata.com. And with that, I just had a very pleasant conversation with my colleague, Philippe Marc, over here. And I encourage you to listen very closely to what Philippe has to say, because he has been on the journey that many of us smaller companies are now just beginning. And the real beauty of hearing and learning from Philippe's story is that this is how science functions at scale. So Philippe is Executive Director and Global Head of Integrated Data Science at the Novartis Institutes for Biomedical Research, NIBR. And to just give you a little bit of teaser of what he's going to talk about, there are 4 pillars of the data management strategy at NIBR, and they are data culture. We just had a really interesting chat about how that works in the remote world. Data management, data science, and data enterprise.